This is Digaris MPC, Math, Physics, Computing, 130 plus courses on Masters and PhD level in pure math and math physics. This is course number 4, MPC4 on linear algebra, lecture number 1, part G. So this now is a more formal summary of the addition and multiplication by scalars of general n-dimensional vectors, arrows or points if you like. So if you have two vectors, you remember the little wiggle just means that this symbol here is a vector. You see the wiggle, you know immediately it's a vector. You're talking about a vector. So if you have two vectors u and v, and they belong to this n-dimensional space, and the r here means that the components of the vectors are real numbers. Okay, so here's an example. We have two row vectors here because they're written in a row, so horizontally. If they were column vectors, they'd be written this way, vertically. So a1, a2, a3, So two vectors u, whose components are a1, a2, an, vector v, whose components are b1, b2, bn. And so to sum them, so you're adding u plus v. Remember, you just add the corresponding components, so you add that to that, you add that to that, and so on. So here's the sum, so u plus v, you're adding two vectors, so you add the corresponding components, so it'll be, here you'll have, so the first component of this sum vector will be a1 plus b1, and the second component will be a2 plus b2, and the final one, the nth component, will be an plus bn. Right? Now, similarly generalizing for an n-dimensional vector in where the components are real, so r to the n. N here's the number of components, the number of dimensions of your vector, of your arrow, if you like. Okay, so now we're taking a vector u and we're multiplying it by a number, in this case a real number, k, so it belongs to r. Remember this r with the extra vertical line here? That r is the set of all possible real numbers, and the corresponding, well, if you have a c and an extra line, that's the set of all possible complex numbers. Alright, so if you multiply this u by the number k, the real number k, you'll get ku. Remember, the mathematicians' definition of a vector is they're mathematical quantities that are addable and you can multiply them by numbers, k. Right, so ku, you just multiply each component, so a1 by k and a2 by k and so on, for all of the components, k, a, an. Okay, so that's the definition of multiplying a general n-dimensional vector by k, and that's the general definition of adding two vectors in n-dimensional real space. So that is the definition for addition of two n-dimensional vectors, and this is the definition for multiplication of one n-dimensional vector by a number k, a real number k. Okay, and note, remember the sum of two vectors has to be a vector of the same kind. So this will also belong, so u plus v, the sum, will also belong to n-dimensional real space, r to the n. And similarly, ku will also belong. Oh, this symbol here, if you've not seen it before, looks like a little epsilon, like the fifth letter of the Greek alphabet. So alpha, beta, gamma, delta, epsilon. And it means belongs to. So this vector belongs to the set of r to the n. That's It's n space, if you like. That's the set of all possible n-dimensional real vectors. All right. Now, what happens when you try to add two vectors where the number of components is different between the two vectors? Well, then the sum is not defined. In other words, you just can't do it. You just can't add them. Okay, so not defined. Okay, now the concept of a negative vector. What does that mean? Well, if your k here is a negative number, let's say -1. So your k here can be a negative number. So so here's your k here, -1. So ku. Now this here is shorthand for this. Now here are these 3 bars again. Remember in earlier sessions, 3 bars, that's the symbol for is defined by. Okay, so -u is defined by -1 times u. Here's your k, right? So this is a kind of shorthand for this. And this gets a bit tedious because of the brackets, so you just leave them out. And you just, you don't even put the 1, you just put minus. So -u is defined by -1 times u. All right. So this is, so we've got vector u minus vector v, and again is defined by vector u plus -1v. So because this minus v here, that's shorthand for -1 times v. Okay, so that you can rewrite, sorry, that is a shorthand version of that. Now, so this vector minus u, it's just simply called, it's just the negative of u, just negative u. Now, in terms of arrows, what would that mean? It means you're reversing the direction of the arrow. So if that's u, that's minus u. Okay, you just, so the size of the arrow is the same. You know, if you're thinking of the physicist vector, just think of the physicist vector is essentially an arrow, where the length of the arrow that represents the size of the physical quantity you're talking about. For example, velocity or electric or magnetic field strength, something like that. Okay, and the direction. So so if you're thinking of the physicist vector as an arrow, if that's, say, velocity v that way, then minus v would be in the opposite direction, but along the same straight line, but in the oppositely directed. And this, so this minus u is just called the negative of u, vector u. And u minus v, that's called the difference, you know, for obvious reasons, between these two vectors. Okay, so u minus v. Now I'm teething problems. I've learned a lesson here. I need to, if I'm going to start a new section, a new topic, I need to have all of it on the same in the same session. But I've just got one line here. It doesn't mean much without the what follows it. But well, yeah, I think I'll stop here and I'll use this line mentioned in the next session. So I'll stop.